Hello everyone, this is Dr. Prashanth and welcome back to my public health series. In this video, I'll be talking about the sample size determination based on precision rate and confidence interval. So before starting that, there are some points to be kept in mind while determining sample size. First is the nature of population. So if the population is homogeneous, we need small samples. If it is heterogeneous population, we need larger samples. Next is the number of classes proposed. So if there are many groups and subgroups, we need large sample so that we can allocate decent number of individuals to different groups and subgroups. Next is the nature of study. For general surveys, we need large sample. But if the study is intensive and continuous, we prefer small samples. Next is type of sampling. So type of sampling plays a very important role in sample size determination. For example, a small random sample is superior to a large sample but barely selected sample. Next is the standard of accuracy and acceptable confidence level. So in order to keep these two high, we require a large sample. Next is the availability of finance or budget. So for large samples, we need more money, right? So larger samples will result in increasing the cost of sample estimates. And some of the other considerations include nature of unit selected, size of the population, availability of trained investigators, size of questionnaire, etc. So now let's start with the first term, precision. As already said, this approach is based on precision and confidence interval, right? So we need to set the precision first. What does it mean? A researcher will have to specify the precision that he wants in respect of his estimates concerning the population parameters. In simple words, for instance, researcher may like to estimate the mean of the population within plus or minus 3 of the true mean with 95% confidence. So what is the desired precision in this case? It's plus or minus 3. So let's understand this with an example. If the sample mean is 100 and the desired precision is plus or minus 3, then the true value of the mean will be no less than 97 and no more than 103. What if the desired precision is plus or minus 4? Then it should be no less than 96 and no more than 104. I hope it's clear. So now coming to the next term, that is confidence level, which I already discussed in my other videos, but I'll just go through it. It is the proportion of confidence intervals that would contain the true population parameter if you were to repeat the sampling process infinitely. In simple words, this gives us a range, a lower limit and upper limit between which the true population mean will fall. Okay, so it's usually expressed in percentage. We all know, right? 90%, 95%, and 99%. A simple example to understand this: if a study estimates the mean blood pressure in a population to be 120 mm of Hg with a 95% confidence interval of 118 less than or equal to mean less than or equal to 122. So what does it mean? In this case, the lower limit is 118 and the upper limit is 122. So we are 95% confident that the true mean blood pressure lies between 118 and 122 mm of Hg. So there is a 5% chance that the interval does not contain the true mean. So we can interpret in two ways. So now let's start with the calculation of sample size for estimation of a mean. So to estimate the population mean with a given standard deviation sigma and ensure the error does not exceed a specific value, that is small e, the required sample size small n can be calculated using the following formula. So there are two scenarios. If the population is infinite, so we use the formula n equal to z square multiplied by sigma square divided by e square. So what is Z in this case? It is the Z score which corresponds to the desired confidence level. For example, if the confidence interval is 95%, so Z value will be 1.96. What is sigma? We know, right? Standard deviation, which measures the variability in the population. Whereas E, that is the margin of error. So the maximum acceptable error or margin of error between the sample mean and the true population mean. And we know mu, that is nothing but the population mean. So in the second scenario, if the population is finite, we use a different formula. That is z square multiplied by capital N multiplied by sigma square divided by n minus 1 multiplied by e square plus z square multiplied by sigma square. So let's understand what is capital N. Capital N is nothing but the size of the finite population. Okay. And Z, we already know Z score corresponding to the desired confidence level. For example, if it is 95%, we take 1.96. Whereas sigma, we know standard deviation, and E is nothing but the margin of error. So I have given two numerical examples for practice. You can just go through them and please post the answers in the comment section. So now coming to the sample size calculation for estimation of a percentage or proportion. So in the previous example, it was estimation of a mean, right? So in this case, we are estimating a percentage or proportion. So we use different formulas. So for infinite population, the formula would be z square multiplied by p multiplied by q divided by e square. So what are these p and q? P is nothing but the estimated proportion. So if you know the value of p, we can get the value of q by 1 minus p. Q is nothing but 1 minus p. So we already know what is Z. It is a Z score corresponding to the desired confidence level, 1.96 if it is 95% confidence interval. And we know the meaning of E is nothing but the desired margin of error. For example, if the margin of error is given as 5%, E value will be 0.05. So for finite population, the sample size calculation formula will be z square multiplied by p multiplied by q multiplied by n divided by e square multiplied by capital N minus 1 plus z square into p into q. So what is capital N? Capital N is nothing but the size of the finite population. And Z, we already know Z score corresponding to the desired confidence level. P, we know the estimated proportion. And the Q value will be nothing but 1 minus P. And E is nothing but the desired margin of error. So now coming to conservative sample size, which is very important. It has been asked many times in UGC. It is nothing but the largest sample size you will need for estimating a population proportion. So it can be called as conservative sample size or maximum sample size. So whenever you see the term conservative sample size or maximum sample size, the value of P should be taken as 0.5. That is nothing but the 50%. Why? Because it maximizes the value of the sample size. So I have given three numerical examples. Please solve them and post the answers in the comment section. I hope it's clear, and I'll be talking about other methods of sample size calculation in my upcoming videos. So if you're having any other queries, please post it in the comment section. Thank you.